Hello everyone, this is Data Dawn again. I'm here to talk about a heartbleed bug in 5 minutes. It's basically what a heartbleed. Everyone is talking about heartbleed. Heartbleed bug is basically a bug which is found in a protocol called SSL, Secure Socket Layer. Um, so that enables anyone to send an anonymous package and retrieve the information from server. So RFC 6520, which is request for standard 6520, defines SSL heartbeats has a uh, as a packet as a message which is sent from any client, anonymous client, to a server just to see if a session is alive. Okay, it is also used in MTU, maximum transmission unit path discovery. Okay. And why is this a problem? Heartbeat request can be sent without authentication to the server. So any client, anyone who is not connected to the server, can send a message packet to ping the server and see if the connection session is alive. So that's what the heartbeat protocol is. It is called heartbeat, just to see if a session is alive or not. Okay, that's what heartbeat is. So the vulnerability, the actual bug is in the code, which does not check the incoming packet. It is basically the bug was introduced in OpenSSL version 1.0.1 code in March 2012, and it is not affected in versions of 0.99 and 1.0.0. The affected versions are 1.0.1 to 1.0.1F, and it is patched in 1.0.1G. Normally the people, they won't patch the servers open SSL, so there is still a lot of server which are vulnerable for this bug. And you can see that introduced code was in November 2011. It was committed on December 31st 2011, just before midnight. Okay, so what exactly is bleeding? So if you see the picture that I'm going to show you, uh, so this is a heartbeat packet that is sent to victim with a payload of 4 bytes. So once the server receives this packet, heartbeat message will be sent to the client with a type and a length and then a payload data. So if any victim, if any malicious hacker, he crafts a special packet with a payload length of 65338 bytes, which is the maximum byte of a packet in which a packet can accommodate. Okay. So in that case, what actually happens is the server, without checking the bounds, it just copies the memory bytes, copies the data from the RAM, and then sends it back to the client. Okay, that's what actually the problem is. So according to the protocol, if the length is greater than 4 bytes, it should silently discard the packet. So that is not happening. So it is basically allowing anyone to send a packet with a payload more than 4 bytes and execute it, and then it sends a response packet with content of the memory. So when you see a content of the memory, the content of the memory can be anything, including the passwords, a valid certificate, or any encrypted key, or any usernames. So if you want to see an example, you can send a packet to a Yahoo. As you can see in the picture, if I send a packet to Yahoo with a payload of 65330, Yahoo is obviously now it's patched, so it can return a value of the memory, which you can see the login ID and password is it's obscurated right now. So this is just an example to show you what can be retrieved using a heartbeat bug. Okay, already the exploit code is in the wild, so people are already started exploiting this bug. um, so that's just to show you the gist of what a heartbeat bug is. So now coming back to the presentation. So as I as I explained before, this bug allows attackers to grab 64K chunks of memory contents near SSL heartbeat. Okay, it is a random chunks of data on memory space. Okay, so it is randomly they get the data, so it is not, you cannot like specifically get a password or a certificate. It all depends on what the data is returned by the server. The attack can be repeated many times to grab different random chunks of data. So uh, if an attacker, he sends a packet, if he keeps on sending the packet, the server will respond, send a response packet with whatever contains is there in the memory. So he can grab anything from the memory, random access memory. So 64K does not seem like much, but it is. So any password will be like 8 bytes. Okay, so you can get any valid amount of data from the server memory. Okay, so that is what the actual heartbeat bug is. Memory disclosure, what can an attacker get? Like I said, if they can get private crypto keys. With keys, he can decrypt any information between the server and the client. So he can be like doing a eavesdropping and packet capturing, and then he can decrypt the information that is being sent from a server and client. He can get the username and password. He can get a session identifier. He can get a private data, an email data, whatever it is, metadata from SSL session programming structure pointers. So especially highly skilled hacker can do anything with these kind of data. Okay. Geeky details the four-part heartbeat. So this slide just explains about the heartbeat packet. Okay, the first byte is SSL v3 protocol length. The second byte is heartbeat type message. And third byte heartbeat message. And fourth is the message data, which is variable bytes. Untraceable and undetektable. So earlier when the bug was released, they said that an attacker will be untraceable and undetectable, which is actually no. We can actually trace the attacker. It is detectable. We can just see if there is any unwanted request coming in, and then we can just come to a conclusion that someone is trying to attack us. So what you can do, you can just change all the password so far, whatever it is created between these period, because it could have been exploited right from March 2012 to 2014, which is like 2 years. So they could have got all the passwords and username. So it's better to change all the password, monitor carefully for any evidence of identity theft. If there's any identity theft in your network, prepare for phishing and social engineering campaigns, leveraging Heartbleed into scamming people, diverging credentials. So also some people use phishing attacks to get the username and passwords. So you got to be careful on all these things. Server side attacks, but I'm not see, you can have a question, but I'm not running any web server, so I'm safe. Yeah, right. No, you're not safe, because you'll be using any server which is vulnerable to these kind of attacks. Like you might be using a Yahoo server or any other server which runs on Apache and the specific version of OpenSSL. So but Windows products are not affected, so I'm safe. No. Windows can be a client, and server can be any Linux server which runs in Apache. While Windows server are not directly affected, many SSL to link or other servers. Okay, I checked everything using TCP before. Am I safe? No. No. The full accounting of vulnerable clients is not yet known. Attacker can redirect the traffic to vulnerability server and to exploit this vulnerability. Be wary of secure network clients. Okay. Safe browsers of Firefox, Chrome, IE. Okay. Internet information services are not affected, not vulnerable. So if your server is IIS, you are not affected. Um, yeah, this is just a funny slide. So most Android devices are vulnerable because they are using HTML5 apps which runs on OpenSSL, the specific version. iOS and Mac OS X are not vulnerable, but specific some iOS apps are vulnerable. The details you can find it in the net. And most of the Linux browsers are probably vulnerable because Linux browsers will have the OpenSSL specific version. The third-party code using OpenSSL could be vulnerable. Okay. So information security is continually monitoring this vulnerability with IDS and IPS services. Vulnerability scanner scans for different um, servers with this vulnerability and send a patching request to them. So if you want to see the code, what exactly is happening, so if you see here the end-to-end payload, so this is where the payload length has been read and it has been sent to pointer. And this mem copy function, it just copies anything starts from p1 to payload. So if a payload is sent as 6535325 or whatever length, so this mem copy function will copy all the messages from the memory starting from PL to payload, which may include the certificates, usernames and passwords, and it will just send back to the client. So that's when the client will get the information which is not supposed to get. So that is what this actually attack is. So thanks for watching. I took more of your time, so please subscribe to my channel, and thanks a lot and have a great day. Bye.